Did an investigation on shifting linear equations, and we look for patterns. How does the linear function shift up, down, left, and right depending on what the equation looks like? So the warm-up is a review of that. For part A, how does the function y equals x plus 5 minus 4 shift from the parent function y equals x? And we learned that if it's inside the parentheses, it shifted left or right. If it was plus 5, it shifted left 5. And if the number was outside the parentheses, it shifted up or down, so minus 4 was down 4. Number 2, how does the function 2 times x minus 3 plus 1 shift from the parent function 2x? So again, the parent function is 2x, so you'll see the 2 there. But when we look at shifting, excuse me, it doesn't affect what's in the parentheses or what's outside. So this one still is left or right. So minus 3 would be right 3. And the plus 1 would be up 1. And we had this last function that was shifted from the parent function, the original function 2/3 x, so you'll see the 2/3. But we have the minus 11, so again the minus means to the right, right 11. And the minus 7 will be down 7. So the rule that we looked at yesterday for any linear function, so straight lines, where we have y equals x minus h plus k. If it's inside the parentheses, if it's the h value, minus h was right h units, plus h was left h units, and then we have plus k is up k units, and minus k is down k units. So the question today is, do these rules apply to something that's a quadratic? So we've spent a lot of time looking at quadratics this year. So parabolas, either U-shaped up or U-shaped down, do the same rules apply. So for investigation, it says sketch the graph of y equals x squared. This will be our parent function for today. What shape is this graph? So again, we spent a lot of time, we know what this looks like. If we want to graph these points, let's plug into x squared. So if I plug in a negative 2 right here, for x, y equals negative 2 squared. Negative 2 times negative 2 is 4. If I square a negative 1 times negative 1 is 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4. Let's graph this. Negative 2, 4 is right here. Negative 1, 1, 0, 0, 1, 1, 2, 4. So we know this is a parabola. So this is our parent function. If I say what is the vertex is where it changes direction, and the vertex is at 0, 0. What shape is this graph? It's the U-shaped graph. We call this a parabola. So let's take a look then at the investigation. In each set of graphs below, the parent function y equals x squared does not have the dots, and the shifted function does have the dots. So here's the original function right here with the vertex at 0, 0, and the shifted one has the dots. For each graph, describe how it shifts and predict the equation. Use your graphing calculator to check your answer. All right, so let's take a look at the first one. The first one, if we look at just the vertex right here, it looks like it shifts down. 1, 2, 3, 4, down 4. And from yesterday, if I make a prediction, if we have y equals x squared, down 4 was on the outside of the parentheses, so minus 4. So let's check our answer. I'm going to pull up my graphing calculator. While we wait, let's see the next one. The next one looks like it's shifted up 1. Equation of the shifted function, y equals x squared plus 1, not in the parentheses, will be my guess. So let's let this load and let's use our graphing calculator to check our answer. Make this bigger. Okay, so let's graph x squared. So there's our parent function. And then my guess was x squared minus 4 to shift it down 4. So I'm going to go to tab and do x squared minus 4. And you can see that it shifts down 4. So my prediction was correct. Let's try the other one, x squared plus 1. Does that shift it up 1? I'll hit tab and go up and get rid of the minus 4 and do a plus 1. And you can see it does shift up 1. So use your graphing calculator to check your prediction. All right, there are 4 more. So the next one is, how does it shift from the parent? It looks like it goes to the right 2. From before, we know this is y equals, and inside the parentheses was the left or right. And yesterday, right was minus. So let's try that. So I'll hit tab and go up. And in my parentheses, do x minus 2 squared. And you can see, yep, it moves to the right too. The next one goes to the left. 1, 2, 3, 4. So for the shifted function, that left to right was inside the parentheses, the squared's on the outside, and we have x plus 4. And we can check that and it will work. And the last two, this has a combination of moves here. So this one goes left 2, but it also goes up 2. So like my equation, left 2 will be x plus 2 squared, and the up 2 would be plus 2. And the last one, this one from 0, 0 goes 1, 2, 3, 4, right 4, and down 2. Equation of the shifted function, right 4 would be x minus 4 squared, and then down 2 would be minus 2. Let's test this one, the right 4 down 2. So I'll hit tab, go up, in my parentheses, right would be minus 4, and then the up 2 be plus 2. And this one does move right 4 and up 2. So it turns out the same rules apply to quadratics as they do to linear functions. So make a prediction, how was the following graph shifted from the parent function? So the plus 4 would be left 4. The minus 5 would be down 5. The minus 1 would be right 1. The minus 7 would be down 7. So the summary for any quadratic, notice the squared's on the outside. If it's on the inside of the parentheses, the only thing on the inside of the parentheses is the left or right shift. So minus h would be right h units. The plus h would be the left h units. The plus k would be up k. And the minus k would be down k units. So what you're looking for is the left or right shift inside the parentheses, and that's the only thing in the parentheses is the left or right shift, and the plus or minus is on the outside of the parentheses. So last two examples. How did the following functions shift from the parent function? X squared, so it's a parabola. Again, the only thing on the inside is the left or right shift, so plus 3 would be to the left 3. Plus 5 would be up 5. Minus 3 would be a right 3. And minus 5 would be down 5. So you're going to practice this looking at quadratics and linear functions today, and then tomorrow we're going to move on to a new function.